create a confidence interval for the mean. A company has set a goal of developing a battery that lasts over 5 hours, about 300 minutes, in continuous use. A first test of 12 of these batteries measured the following lifespans in minutes, and there's the list of lifespans. Is there evidence that the company has met its goal? Create a 90% confidence interval. Well, the first thing, as always, is we have to identify the parameter. And the parameter of this is going to be mu equals the average lifespan of a battery. After we have our parameter, we now have to check our assumptions and conditions. So, independence assumption, we're going to assume that each battery is independent of the other. Randomization. Now here, they didn't take a random sample, they just took 12 batteries for preliminary testing, but we're going to assume that these batteries are representative of all the batteries. We also have our 10% condition, and 12 batteries are fewer than 10% of all batteries. And then finally, nearly normal condition. And based on the normal probability plot, we can see that all the data that we have, their expected z-scores, lie in a straight line, and therefore it is roughly symmetric and unimodal. So that means all the conditions are met. We can now create a one sample t interval. Well, we have to identify all our key information, n being the sample size, degrees of freedom, remember that's n minus 1, sample size minus 1, so here it's 11. Our mean, x bar, is 306.25, and our sample standard deviation is 29.31. And all those numbers there I got from my calculator. I'm then going to start to find the confidence interval. And our formula for confidence interval is x bar plus or minus t star, which is our critical value at degrees of freedom 11, times the standard error of x bar. Well, the first thing I need to do is find t star. And the way I do this is I'm going to take 1 minus the confidence interval that I want to create and divide that by 2. That gives me 0.05. I'm then going to use my TI Inspire to find t star. And so the first thing I do is from the home screen, I'm going to press calculator. When I'm in the calculator, I'm going to press menu. Then I'm going to go to statistics. From statistics, I'm going to go to distributions. And from distributions, I'm going to go to inverse t. Okay. Since we're using a t interval, I want to do inverse t. I'm then going to put in the area, which is what I calculated, and that was 0.05. I'm going to use the degrees of freedom for this particular one. It's going to be 11. And then when I calculate it, or when my calculator calculates it, I get negative 1.796. Now what I'm going to use is the positive value when I plug it into my confidence interval formula. So now I can plug everything in. I know my x bar, the mean of my sample, was 306.25. My t star is 1.796. That's what I got from my calculator. Standard error is sample standard deviation, which was 29.31, divided by the square root of the sample size, which in this case was 12. When I calculate it, I get 291.05 and 321.45. Now that I have my confidence interval, I'm going to interpret. I am 90% confident that the mean battery lifespan is approximately between 291.05 and 321.45 minutes. With that, I can now answer the question. Because the interval captures 300 minutes and also shows values that are below 300, remember, we want to know if they exceed 300. We cannot conclude there is evidence that the average lifespan of a battery exceeds 300 minutes. So you got to be very careful with that. When you're interpreting it, you have to look at the question. We want to see if it exceeds. Our interval shows that some of the batteries are actually below. Okay, so that means there's not enough evidence to conclude that the batteries will exceed. Now that I have done my interpretation and I have answered the question, I am done. So if you have any questions, please be sure to ask.